Hi everyone. Today we're going to work on IXL assignment 8-3E, irrational numbers on number lines. So before we actually get to that IXL assignment, we are going to quickly review some rational numbers. So we're going to review both our perfect squares and our perfect square roots, and you'll see why in a moment it's important to review this first. So your perfect squares, they're called perfect because you end up getting a nice perfect number. We don't have any decimals, we don't have any fractions, there's no estimation that's required. So if we look here, 1 squared, which is 1 times 1, is 1. That's a perfect square. And then 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. This list here shows your perfect squares 1 through 15. If you want to memorize all of that, you can, but memorize at least through 12 squared, which is 144, because those are the ones that are most common and the ones that you'll run into more often. So not only will that help you with this assignment and future ones, it will be a benefit later on in further years. Just like memorizing your multiplication facts makes other things go quicker if you're able to, quickly know what 3 times 4 is, what 9 times 8 is. Knowing these perfect squares will benefit you in the same way. It'll make other tasks a lot easier if you just know that 8 squared is 64. The other side of this, and the side that you're going to be seeing a little bit more often on the IXL assignment, would be our perfect square roots. So this is the inverse, it's the opposite of our perfect squares, because when you take the square root of something, we are undoing that exponent. So let's actually not look at the first example, because anytime you deal with ones and twos, it's kind of weird. So let's come down here and look at the square root of 16. So when you take the square root of 16, you want to think what number multiplied by itself will give you 16. Well, that would be 4, because 4 times 4 is 16. So that's considered a perfect square root because we were able to take the square root and get a nice whole number. There was no estimation involved. And then same with down here, the square root of 49 is 7, because 7 times 7 is 49. So having these memorized 1 through 12 as well will be really beneficial. And because they're related, hopefully it'll be easy for you to memorize both, because if we look at this, 4 squared is 16, and the square root of 16 is 4. That's why they're inverses of each other. This will be even more of a benefit because, when you see these square roots, being able to recognize that the square root of 81 is 9, and being able to do that quickly will be a big benefit. So make sure if you don't already have these notes down that you've, paused and taken a screenshot, or you've, jotted them down so you can work on memorizing the perfect squares and perfect square roots 1 through 12. All right, now let's head over to IXL so we can see how this is going to help us with our non-perfect square roots and how we can use that to assist in our estimation. All right, here we are on IXL assignment 8-3E, irrational numbers on number lines. So our first question here says, which point on the number line shows the position of the square root of 46? Now, we just worked on our perfect squares. Is the square root of 46 a perfect square root? Well, I know that the square root of 36 is 6. And the square root of 49 is 7. And there is no whole number that falls between 6 and 7 because we want to know the square root of 46. Oh, that means that we know, so the square root of 46 must fall somewhere between 6 and 7 on our number line. So if we look at our number line here, point A is between 4 and 5, so that's too low. Point D is between 8 and 9, so that's too high. But looky right here, point B falls between 6 and 7, which is what we said it would need to fall between. So therefore, point B is that approximate position of the square root of 46. So we're going to do some more examples like this, but this is how you can use your knowledge of perfect squares to help you estimate the value of non-perfect squares without using a calculator. So what we just did as a quick little recap is we're like, all right, we need the square root of 46, but I know that isn't one. So I'm going to find the closest perfect square that is a little bit lower and the closest perfect square that's a little bit higher, which would be 36 and 49. Therefore, 46 falls somewhere in between, and that means it falls somewhere in between 6 and 7. All right, next up, which point on the number line shows the position of 2 pi? You are going to have some problems that don't have perfect squares because this assignment is just any type of irrational number, and those non-perfect squares and numbers involving pi are kind of the two most common irrational numbers that you will be seeing. Well, even though pi is an irrational number, it continues to go on forever and ever without stopping. That's what makes it an irrational number. We can use an approximation for pi to help us figure this out, because once again, the purpose of this is to be able to complete it without the use of a calculator. Well, most of you are hopefully familiar with this, but the most common abbreviation for pi, or the approximation for pi, would be 3 and 1400ths, or 3.14. So we can use that in place of pi. So if our question says we want to know what point on this number line represents 2 pi, that means we can take 2 times 3.14. And then because I have a decimal involved, I'm going to need to do my multiplication vertically, or at least I have to. You might have another strategy. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. So our approximate value for 2 pi is 6.28. So if we check out our number line here, that would be B, because here's 6, here's 7. B would be approximately 6.28. All right, let's do this one. That other one was pretty similar to that first question we did. So let's try this one out. We want to know which point on the number line shows the position of the square root of 33. Well, the square root of 33 is not a perfect square. So what we need to do is we need to find the two closest perfect squares to that. So the first thing that my brain thinks of is when I hear 33, I think of 36. So that's a little bit more. So the square root of 36 is 6. That's a little bit more than 33. Now I want to find one on the other side, so one that's a little bit less. If you don't have these memorized, if you at least get this one and you look at it and say, well, 6, one number less than 6 would be 5. And you can kind of do it backwards. 5 times 5 is 25. So the square root of 25 is 5. These are our two whole numbers, 5 and 6. that fall around the square root of 33. That tells us that the square root of 33 is somewhere between 5 and 6 on the number line. So if we look at our answer choices here, I know it can't be A because that's close to 3. It can't be B, that's close to 4. But both C and D are between 5 and 6, so we have two choices. This is where we now look at our square root number. So is 33 closer to 36 or closer to 25? Let me say that again. So now we know it falls somewhere between 5 and 6, but I got two choices. So is 33 closer to 36 or is it closer to 25? It's closer to 36, meaning our approximate value as a decimal, or in this case on the number line, is going to be closer to 6 than it is to 5. And that would make our answer D, because D is closer to 6 than it is 5. So this assignment, one of the reasons I like it is it, has a little bit of that problem solving there. It's a little bit of a puzzle where you kind of got to work through your different options and see what's the best approximation, which point is the best at showing where it would be. All right, let's try this one, and then we'll see if we go up into a super high SMART score here, and we might do another one or two more after that. So this one is another one with pi. We want to know what number here shows the approximate position of 4 pi. Remember, we can use the approximation of 3.14 to represent pi. And then all we have to do is that multiplication. And that will give us the approximate value of 4 pi. 4 times 4 is 16. 4 times 1 is 4. Plus 1 is 5. 4 times 3 is 12. So we're at 12.56. If I look at my answer choices here, that leaves me with A. And that works because we're saying it's a little bit over 12.5. And that point A is just a little past that tick mark, representing halfway between 12 and 13. So 12.5. All right, let's try this one. What gets us here, what's going to happen when you get higher and higher in your SMART score is if we look at our number line, all of these numbers are between 9 and 10. So it's getting closer and closer. It's not as broad of an estimation. We're trying to get a more and more accurate picture of exactly where the square root of 99 falls. But even though that's the case, we're still going to, let's still start off with the same thing because I'm a visual person. I need to see those surrounding perfect squares. So 99, not a perfect square. We don't know what it is. Well, we know that 10 squared is 100. So the square root of 100 would be 10. So that's a little bit higher. Now I need to go the other side a little bit lower, which would be 9. And 9 squared is 81. And that then confirms that IXL didn't make a mistake. We've, realized, all right, we're between 9 and 10 here. So let's look at the number within our square root. We have 99. Is that closer to 81 or closer to 100? It's really close to 100. It's literally one number away from 100. Therefore, the point that we're going to choose is the one that's going to be closest to 10 on our number line, and that would be right here, point D. That is our best approximation. So it would maybe be something like 9.8 or 9.9, something like that, super close to our 10. All right, that is going to close us out here, guys. If you have any questions, make sure you email your teacher, or of course, Remember that IXL will explain what you did wrong. They sometimes even have those own videos that you can search up. That's a great way to get some additional help through IXL and hear it in a different voice. All right, it's your turn to try. Good luck. I know you can do it.